Hey, it's Mr. Lum again, and today in Chemistry 11 we're going to be talking about unit conversions. Unit conversions is simply like taking one thing, like height for example, and changing it into a different unit. So for example, if you were 185 centimeters tall, and you're going to take 185 centimeters and change that into feet and inches, like 6'1". And we're going to be doing that, but we're going to be talking about different things that relate to chemistry. Now, before we get into that, we're going to get some practice doing some basic unit conversions. So what we have here is we have this question that says a car drives 40 kilometers in 2 hours. What is the average speed of the car in meters per hour? So we're going to have to take this 40 kilometers in 2 hours and change this into meters per 1 hour. So how we can do this is we can write 40 kilometers, and that car drove 40 kilometers and it took 2 hours to do it. Okay, so what I can do is I can take this and I want to change this into meters. So what I'm going to do is I'm going to divide this by kilometers, and I want meters to be on top. So essentially what I want to do is have kilometers cancel out, kilometers divided by kilometers, that's going to cancel out or just be 1. And then what I'm going to be left with is something that is meters over an hour. So my unit is going to be meters over hours. So how many meters are in a kilometer? So if you have 1 kilometer, there is 1,000 meters in 1 kilometer, and so therefore I'm going to go 40 divided by 2 times 1,000 divided by 1, and what I should get is, so I'm going to go 40 divided by 2 is 20, times 1,000 is 20,000. So I'm going to get 20,000 meters per hour. Okay. So what about if the question asks, what about meters per second? So I'm going to take 40 kilometers in 2 hours and change that into meters per second. So what I can do to save a little bit of time is I'm going to take my old answer right here of 20,000 meters per hour, and I'm going to change this into meters per second. So I already have meters up here, so I want to keep that, so that's no problem. Okay, but I want to get rid of this hours. So again, if this is on the bottom, I'm going to go hours on top. Okay, and I want seconds to be on the bottom. So now what's going to happen is hours are going to cancel out, and that's going to equal something that's meters per second, okay, because that's what my unit is left. Now, how many, if I have 1 hour, how many seconds are in there? Okay, so what I can do is I know that there's 60 seconds in a minute and 60 minutes in an hour, so it's going to be 60 times 60, or in other words 3,600 seconds are in 1 hour. Okay, so what I'm going to go is 20,000 meters, or 20,000 divided by 1 times 1 divided by 3,600, or just go 20,000 divided by 3,600. And what I'm going to get is I'm going to get 5.55 meters per second. And I'm just going to make sure I got that right and type it into my calculator. 20,000 divided by 3,600 equals, and that's 5.55. Now, it's going to be 5.5555, or in other words, I'm going to round that, and it should be 5.56 meters per second. And that would be my answer right there. Okay, so these are some basic unit conversions that we can do here. Now, in chemistry and in science, we're mostly going to be using what are called SI units. SI units are International System of Units. Now you're probably thinking, well, why is this IS units? Why SI units? Well, it was developed in France. SI units were, so it actually means System de International Units, and but in English we say International System, but we still say SI units. It's designed to be easy to use, and it's all based on multiples of 10 for the most part. So we will be using things like meters, grams, I'll explain that one in a second, time and temperature, and we'll be using moles. And some of these other ones right here is for physics. Now, SI units have two parts to them. They have what is called a base, and then they also have prefix. A prefix to them. So let's take the example for mass. So the base unit, well, it wrote down kilogram here, and that's kind of the base unit, or the common unit to be used in physics, but in chemistry we often use gram. Okay, now, so gram, and the symbol for gram is just simply G. If I was to convert this, I would to kilograms, like to talk about a person's weight or something, well, we can use the prefix K, which stands for kilo, and then gram. Okay. Now, you can have megagrams, teragrams, and all kinds of different things. And we use quite a bit of these things. So a computer thing that we're all very familiar with, the base unit is a byte. And then you have kilobytes, megabytes, gigabytes, and terabytes. Okay? And but for chemistry, we'll be using milligrams and kilograms quite a bit. So what these numbers over here mean is that one kilogram is going to contain 1,000 grams, or 1 kilo is going to be equal to 1,000 of the base unit. So it could be kilogram, or could be, if we use meters, it'd be 1 kilometer is equal to 1,000 meters. 1 gigagram is equal to 1 billion grams. Okay, and we can go the opposite way too. Okay, so 1 milligram is equal to 0.001 grams. So these are what we call our multiplying factors, our prefix symbol, and just how we pronounce the prefix. Now, you can get into some interesting units called derived units. And a derived unit is just simply a unit which is made by combining two or more other units. And sometimes they give them a special name for these, and often we just say, like, a derived unit, we just have shows a little formula. For example, a very simple derived unit that we just used before is when we had meters per second in the last problem there. This is a derived unit. Okay, it is one unit over another unit, and they can be multiplied and so on and so forth. Now we'll take a look at this question right here. using the formula, delta H equals Cm delta T. What is C? Now, this is a formula to calculate specific heat capacity and a little bit of that kind of stuff. But we're going to be just using this problem to talk mostly about derived units. Now, so what we're going to do is we're going to take this formula and plug in our values. So we're going to go 40,200 joules is equal to C. Our M is 175 grams. And delta T is 55.0 degrees Celsius. So I'm going to isolate. We want to find out what is C, so we're going to go 40200 joules divided by, I'm going to divide 175 from both sides, so it's going to be 175 grams, and divided by 55 degrees Celsius from both sides. And that is going to equal C. So what we get after we do this, if I go 40,200 divided by 175 divided by 55, we get C equals 4.18. Now, what is the unit of C? Well, just like how we did here, we had 40,000 divided by 175 divided by 55. We do the exact same thing with our units. We just simply go joules divided by grams degrees Celsius. Okay, and this is going to be our unit. Okay, and so this is what we call a derived unit, which has simply a couple of different types of units combined into one. Okay. Now, density also deals with a derived unit. Density is a material's mass per unit volume. So it could be, grams per milliliter or kilograms per liter. Those would be all different types of units of density. So it would just be a mass, grams, per a unit of volume. So like milliliter. Okay. Now, so mass is just the quantity of matter in an object. Volume is the amount of space the object takes up. So let's take a look at this one right here. An iron bar has a mass of 19,600 grams and a volume of 2.50 liters. What is the density of this thing? Now, we're going to make this, we're going to answer this question and answer it in grams per milliliter right here. Okay, so we're given grams per liter. So we're going to write down 19,600 grams over 2.50 liters. Okay, now I want to have this in grams per milliliter. So again, we want liters to go away, so we're going to go liters. Now, how many milliliters are in a liter? Well, it's going to be 1,000 milliliters is in 1 liter. So what's going to happen is our liters are going to cancel out, and our answer is going to be in grams per milliliter. So what we're going to do is we'll go 19,000 divided by, 19,600 divided by 2.5 times 1 divided by 1,000. And what we get is 7.84 grams per milliliter. Okay, and so what we did is we have a derived unit, and we also did a very quick unit conversion on this one as well. Now, the next question says, will this object float or sink in water, and why? What I want you to do is take a look in your textbook and tell me if this thing is going to float or sink in water, and we'll discuss that in class. Okay?